Right. Hello, everybody. Let's see if this goes smoothly today. All right, then. So, what are we doing today? Yesterday, we were doing some stuff to do with the assembly variants and making sure we got the list of components from the list of placements. And then once we had that, we have to map the placements to the parts that are available so that we get a list of stuff at the end. I carried on a bit yesterday afternoon, did a few more bits and pieces to the code so that it now does more like what we actually wanted to do instead of what it was doing at the end of last week. Right, so yeah, let's see. So let's pull up the IDE. Oh, I've not even got it open. Hear me. Right. Rust Rover. Let's go. All right, let me resize that. There we go. Jobs are good. Righty ho. So. Let's just run all the tests, make sure everything's happy. I also rearranged a bunch of the classes, the structures, implementations into various different modules and so on, so that we can navigate our way around the project a little bit better. That had an impact on some of the dependencies for the project. So some of the dependencies that were only dependencies for the CLI are now dependencies on the library because some of the code is moved out of the library. At some point, we'll go back and then move the CLI tool into its own crate and then fix up the dependencies. And then some of the core concepts will move into another crate, which then don't have the dependencies. So that happened. So let's find the main test first. Let's close all the tabs. There we go. Right. So let's have a quick look at the structure of things now so that we can see sort of where we are with all this. We'll keep these here and let's just look at this to remind ourselves of what the input to this thing is. Right. So names and values and refdeses. Right. So now if we look at the source, we see that we've got stuff to do with assembly, we've got stuff to do with EDA, we've got loaders, we've got part mapping, we've got PnP, and we've got util. So in PnP, we've got the important things that are parts and placements. And there's nothing to do with CSVs or anything like that in this. This is literally just a part and a placement. So the loaders is where all the CSV stuff is currently happening. Now, remember, yesterday I was saying that there's going to be different ways of loading this information. So the parts might want to come from inventory, for instance, or some other third-party inventory management system. So we need to load them from somewhere. So I just call them loaders for now. And we've got CSV-related stuff. Right. Then in EDA, we've got stuff to do with what the EDA tools give us. I'm still not sure whether assembly variant is an EDA concept or not, but we can move it later if we find out a better place for it. But we've certainly got an EDA placement, which is one of the things that we're dealing with the other day. And then we've got some dip trace specific stuff. So we've got our dip trace criteria and so on. We'll do more work with that at some point. And then we've got some CSV related things, dip trace records, it's all specific to dip trace, right? So they live in that. So I'm fairly happy with sort of that so far. And then we've got the assembly, where we basically get the placements that the EDA placements from our pick and place file, and that then gives us the variant that we want. So we've got all that. So that's all fine. And then we've got the binary, which is the thing that's driving all the rest of the code at the moment. Now, I'm very mindful that we've got a CLI tool and we want it to do things, but we're also going to want to do the same things that the CLI is doing or will do soon in a GUI application. So we have to be very mindful that however we structure things, we have to be able to keep sort of the underlying business logic side of things, as in ask the user to choose something, that concept, and like ask the UI to resolve something or whatever like this. It has to be workable for both CLI and for GUIs. So very mindful of this. So what's left in here? Let's have a look at the structure. So if you remember yesterday, there was like loads of stuff in here, and that's now all disappeared. So we've basically got, the main, which basically says build assembly variant, and yeah, and it loads placements, it loads parts using a loader, and it loads up part mappings, and then it uses a variant processor to give you a bunch of EDA placements essentially, and then it matches them, prints out how many matched, and then we use the part mapper to get a hash map of EDA placements to part mappings. Hash map of EDA placements to part mappings. Right. So what does this look like when we try and test it and when we try and print those out? So let's run this. Which should be this one. Right. Can we see the output? Not very easily, no. Okay. Let's put a breakpoint in the test. Yeah, somewhere here. Right. Get rid of this. Right. So now if we look at the console, yeah, we don't see it. This is one of the things with Cargo that's a bit funky. If your tool is printing stuff, like it gets captured by the test, and you don't get to see it. The only output you see is the output from the test itself. Why is it? Hold on a second. Why is it doing that now? That's weird. Yeah. Yeah. Tell you what, so that we can see it real quick, we're just going to make it. We're going to make it fail. I know how I've done the show the capturing stuff before, but I don't want to deal with it right now. I want to focus on what we're doing. So what it prints out, we're trying to see the hash map that it prints out, right? Like what's in that hash map. And one of the other things we can't do is attach a debugger to it at the moment as well. I still haven't worked out how to attach a debugger to the code when you run it through Cargo. So what it looks like is that you've got an EDA placement, which is a dip trace one, which has the following details, and that part is mapped to a resistor manufacturer's resistor 1 part. Ta-da! Amazing. That's what we want to do. And it used this criteria to do it. And then we've got another EDA placement, J1, with the following dip trace details, which mapped to this connector using the exact match criteria. That's what we want to do. Amazing. Brilliant. Now, things aren't so simple in reality. What can happen is there can be situations where you don't have any parts defined, you don't have the correct criteria, the criteria didn't match the part due to like some typo, or either in the criteria itself or the name of the value in the EDA tool, or where in fact there are multiple parts which could match. In the case where there are multiple parts that could match, one of the things that we need to be able to do is find out what is currently in the machine itself and suggest that as a default, if that was appropriate. So there's two things. We need to be able to ask the user how to resolve a situation where there are multiple matching parts. So what we're going to do is try and create a more low-level test at the moment to do this, so that we can experiment with just the selection process rather than all the other side of things, and see if we can work this out a little bit. So if we go back to the tests, we've got this test, and it's our sort of like happy case test. It doesn't print anything out yet, and it doesn't assert that it actually mapped. It doesn't assert the details of which placement goes to which. It probably should do that, really. But, and this is where my hesitation comes from, is that we're going to have to format somehow this list of things and display it as a list, and then assert that it's there. I suppose we can probably do it. Hold on, let's think about this. Yeah, okay, let's do that first, and then we'll come to working out the tests for like resolving multiple matching parts. So let's just say, and then this is what our hash map contained. Let's just say we want to make sure that R1 mapped to these two things. Let's just assert that. And we'll print out the details of it as well. So let's say, and contains, and let's say expected part expected part mapping 1. And 2. And instead of putting these here, I'm just going to define these up here. So because I know at some point I'm going to have to come back and change these things. Let's do it. Let's do it here. So we're going to say that it ends with line feed. I don't really care that it contains a line feed, actually. So we're going to say R1, which is this. Yeah, use single quotes here. Goes to no. Tree. I'm going to say the word tree, and you're going to be like, why? And why are you saying tree? Why? God damn it! Because there is sort of this potential weird resolution tree which is going to happen, and I want to print the details out of it in a way that makes it easy to understand what the hell happened and why it happened. Tree. Not that kind of tree. Rust. Crate. Tree. Let's see. Oh dear. Oh, I don't think this is going to be it. General purpose tree structures. No. Let's search for an ASCII tree. ASCII tree. Here we go. No, not that one. Let's find another one. Yes, that's what we want. We want an ASCII tree like this. We want an ASCII tree. Now, the reason I brought this up is because I don't know how to type this character on the keyboard. Right. So, what we're going to say is that we're going to use this. Remember, we had this indoc thing we did? Yeah, we used this indoc thing, didn't we? Where do we use that? Here. Yeah, what's happened here? No, the formatting's gone funky. Right. So we did this indoc thing and it worked like this. So we're just going to plop this here for the moment and delete all this rubbish because we don't want it. So what we're going to say is that R1 it's going to be some of this. Here we go. Right. So, right. R1. Do we want to print out all this stuff here? Yes. Probably this is fine. And then what we're going to say is this. And we're going to say, let's use this one first. Because I don't think there's any more that we care about right now. And we're going to say it was mapped. Well, yeah. Yeah. This is what we're going to say. R1 is this. I think that's what we want. Now, why has it got red lines here? I think it's because the quotes. I'm not escaping the quotes. Yeah, we're going to use single quotes. Backticks. That's backticks. Single quotes or backticks. Single quotes or backticks. Let's go with single quotes. Let's go with single quotes. Normally I use single quotes for this stuff, not backticks. Even though in like all markdown tools and all this kind of stuff, backtick is sort of like the symbol for like code or whatever. But it's all kind of like this, you know, it's not code. Monospaced fonts, that's what I'm after. Monospaced. Mostly monospaced. Right. So this is what we want. Great. Fine. And we want another one of these. And we're going to say, and I don't care about this criteria yet, but I might later. And we're going to say that J1 with this name and value with single quotes. I'll come back to the quotes in a moment. Maps to this part. Right. Plop. Okay, and we'll deal with quotes now. IDE is auto completing my quotes. I don't like the way it does that, really, to be honest. Right. So that's what we're saying we want. That's going to be pretty good. Righto. Yes. There is some clarity there. Oh, oh, oh. There we go. It's got to be one of them. And you don't need to print the line feeds on this because indoc will do that for us. Right, so now we're going to have a failing test. It's not going to run. It's not going to... Oh, mismatch closing delimiter. Oh, yeah. There we go. Try again. That's it. Oh, yeah. It should. We can fix that. And this is why I like this IDE. It's just great for just like this stuff. It really is. Like if you're using like VS Code or Eclipse or whatever like that, it's like the helping stuff in this IDE is amazing. It just fixes it. You don't have to search for it. You don't have to rename it. You just enter, enter all day long. Brilliant. Man, I'm an advert for JetBrains. I am today. Maybe they should sponsor me. Eh? What do you think? Do you reckon I can get them to pay for the next license? Should be able to get some licenses for this actually because they do sponsor open source stuff. They sponsored the CleanFly stuff before. Right. Anyway, getting sidetracked. So we need to print out this tree. Basically, we need to do something with this. But I don't want to deal with that right here. I want to just go something like, what do I want? I suppose build resolution 3. Sure. And we'll give it some match mappings. Seems reasonable. And then go I don't know how this API is going to work, but this is the kind of thing I want to do. I've had a little bit of experience with these things that create these trees, and it probably works the same way. It's probably going to create some node kind of like graph thing. And we're just going to say tree print like this. I guess we're going to make this work somehow. Let's have a look. So what is this? This is our matched mapping. And it's going to give us back something, but I don't know what it's going to give us back yet. Let's go look at this. Let's go and give a look at this. A few people use it, not many. Let's see if there's any other ones. All-time downloads. Huh. There's pest ASCII tree, and then there's ASCII tree. But well, that's not good. No, I think ASCII tree is dead. What's this? Well, that's not ideal. a text tree. Yeah. 4 years old. Oh God, no. Go away. Do, 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 do. Yeah, I'm just sort of looking to see. Let's have a look. It's got a usage example. Yeah, you create string tree node. And you do the stuff. Yeah, pretty much. Don't like this API. I don't really want to do this. Don't like that API. Let's have a look at this one. Is there an example? Oh, it uses. No, this is no good. We just want the trees. Now I have written this in Groovy recently. One of these text tree things, and I'm kind of surprised to not find one with a nice API as yet. Let's have a look at this text trees a bit more. You've got this with children. It takes two things. You see, I don't really want to be putting all my code inside one of these things. I mean, it seems fairly comprehensive. That's the word I'm looking for. Let's try it. Let's try it. What other search terms might we be able to find? Let's do a Google search for it. Rust ASCII text trees. Let's search for images. Okay. Oh, that's interesting. No. So we looked at this one already, right? And then we got, did we? Right, we've got text trees. Yeah. ASCII tree generator. What's this one? Have a quick look at this. Yeah. You know. I wonder how Cargo Tree prints its output. We can actually look at that. Because there is this. You get this dependency graph. Let's have a look at the source for Cargo Tree. See what it uses. Because everybody uses Cargo Tree, right? Source. I guess it's this one. Archived. Integrated into cargo. Okay, fine. So let's look at the cargo source. And I don't know where this stuff's going to be. We can find it in the repository, maybe. Tree. Oh, here we are. But look at this. Tree. Yeah, here we go. Look. This. Subcommand. Can we see tree somewhere? This is tree. Tree options. Build and print. Here we are. Yeah. That's the stuff. So it's in cargo itself. Damn it. I was hoping to find a dependency. Huh. Well, okay. It's not very generic, and it's kind of mixing. It looks like it's printing mixing the display, the presentation code with the logic for the trees. So we shouldn't look at this anyway. No, we're going to go with text trees. Let's have a look at its dependencies first. Choosing packages is tricky. Right, cargo dependencies. None. What we want. That's what we want. Yeah, I don't want to be stuck with some random old craft which has got loads of old dependencies in it. This seems okay. Okay, let's try using it. Righto. Yeah. Okay. Where's my thing? No, not that. This. That's it. This. Right. We're having a text trees. 0.12. This is what I was saying about, there's some reasonable quality stuff out there, but it's all very, very new. Bit bleeding edge. Okay. All right. Let's see if we can do something with this. So, how are we even supposed to do this? Go back to the documentation. There we are. Creates a string tree node. Make tree. Can't I just make loads of string tree nodes and then add them to a mutable tree as we go, rather than all this stuff? I mean, you could probably do this whole sort of filter map malarkey. I've had too many years of OO programming and so on, and yeah. String tree node. Let's say root. Let's see. What am I doing? What am I doing? What language am I programming in today? Who knows? New. Okay, and it wants a string, and then we're just going to say. Well, I don't know what we're going to say actually. Yeah. So in my little list, let's go back to the test for a moment, because this is I don't know, an issue, because I don't want to print out a line underneath things and indent all the tree nodes, and I don't need this sort of like root. I don't want the root one to be printed. I just want all the children to be printed. Because what we said was this. We've got two of these things, so we haven't got this sort of thing underneath it on the left-hand side of these things. So here I've essentially got a root and a child, right? And then I've got another root and another child. But to print out an entire tree in one go, you need a root object with a child and children and children. Let's see. Let's have a look at the documentation for this. You go make tree. And it did say something about printing the root. So this is what we want, like this. We've got root. Yeah. Okay, we're going to have to sell our souls a little bit. Just because of the tool that we're using to do it. It doesn't seem to support not printing. At least I couldn't see it here. It doesn't, we're always going to get these bits. We're going to use this one. And they're always 4 wide, which is fine. Let's do this then. Let's build a tree. Sure. And the way it's going to work is that there's this thing. But I don't really have a name for this thing yet. I don't really care about it. So it's going to be like that. And then underneath start of this, it's going to have this, right? That's what it seems to want. And then the last one of these has got one of these, which is going to be like this. Then this is going to be indented like that. Then we're going to need one of these there. That's fine. I suppose we could say I don't know how useful that is to anybody. Mapping results, mapping tree, fine, whatever. Don't really care. So, mapping tree, happy days. Are we going to say result? Can this fail? No. I don't think it can. Right, so we've got this. So we're going to say root for now. We're going to return it. Okay. We've got a tree, and we're going to print it. I'm just going to put it now. But is it print? No. Okay, what can we do with the tree? We can write it. So we need a standard out writer or something, probably. Let's have a look at the example. Oh, look at this. You can use emojis. You can use emojis. Oh, that's great. We might do that. This is another reason why I like Rust, because you can just put emojis in the source and everything's fine. And all the IDEs and browsers and everything's not browsers, IDEs and things support it. It's just the future, isn't it? Look at this. Oh yeah, we can get well fancy with it. Not today. Right, so we're doing this. Right, yeah, here we go. Look, this tree right, wood writer. This is what we want. Oh, it wants to unwrap it. Let stood out writer. It's going to be this. Is it? No, it's just stood out, isn't it? Look, it implements writer, so it's fine. Right, and then you have to. Why do you have to unwrap this? What does write? What does write give you? It gives you a result. Fine. Fine. So that's what we want to do. Let's see what happens. Okay. See, look, we've got trees in here, look. Actually, that's interesting, isn't it? Because this predicate thing is using ASCII trees. I wonder what it's using. I wonder what it's using. Got these predicates. Where's... Hold on. I'm kind of curious now. It does make sense to look at this because we're already using this. We already have it as a dependency. Let's go back to the test. So it would be nice to check this first. So this contains thing is what's doing it, right? Which is in this predicates crate. So let's have a quick look at the dependencies for this. Difflib. Predicates tree, look. Predicates tree. What does it do? Okay, wasn't expecting that. Render case as a tree. Case tree? What's a case tree? Where's this? Oh. Don't think it's that though we want. I don't think that's how it's formatting things. Hmm. Might be this difflib. No. Might have to use I'll go tree. You see, what's printing these trees? I guess what we could do is search for this. What do you think? In my dependencies. Let's go. Termtree, look, Termtree. That's where it's coming from. Yeah, here we are, look. So we already have this as dependency. So let's have a quick look and see if we can find this, because it didn't come up in my search on this. My Google food's no good. Termtree. Oh, look. That's the one. 34 million people using it because it's used by everything. It's used by loads of stuff. Right. Let's have a look. Yeah, okay. API documentation. Let's have a look at this one. Okay. Tree. Get a tree of type strings. Yeah, no, well. Set multi-line. Yeah, okay. All right. This looks pretty reasonable. Let's have a look at the repo for an example. No, that's the wrong one, you muppet. Termtrees. Let's see if there's an example. You see, the Rust ecosystem is just brilliant because everyone's using like cargo and everyone knows where you go to the examples directory if you want to find an example of how something's supposed to work. And if you're in like C or Java land, well, there's no consistency between all the sort of like crates and crates packages basically. Is what I'm saying. There's no consistency between the packages that you might be using. Yeah. So happy days. Let's have a look. What do you got to do? Main, you go. So tree gives you an IO result of tree, and you print the tree and it knows how to format itself. Okay, good. So you can just print it instead of having to get the stood out and use a writer and all this kind of stuff. I like that better. And you create a new tree. Yeah, using fold. This is kind of what I expected to see. And then you create entries and add them to the node. That's the API that I was looking for. Perfect. Okay, so we're using term trees for this. Other dependency be gone. Other dependency be gone. This one. I'm sorry. I'm sorry, text trees. I'm sorry. And maybe it's not 0.1. Oh, 0.4. Still 0. It ain't finished. 0. This whole Semver version thing is weird. You know, the first time you release something, it's like, it's version 1, okay? No, it's version 0. What? But it's the first one. No, it's the 0th one. We move on. Okay, right. So this is what we're trying to do. We're trying to use it. I've lost my file. Okay, but I'm glad we looked at that because now we don't have any additional dependencies to the project, which is great. No additional dependencies. Happy days. Bin, parent, build, right. Tree. So no. And then we do print run. Whoops. Tree. Instead of that. This is apparently what we want. Yeah, okay. Was it a type string? Yeah, I think it was. Okay, so we go 3 new. Okay, but we need to put something in here. Let's look at the documentation for it. Again, sample. It said you create a label. Oh, this is interesting. But this is doing it for a path. But as long as it gives you a string, you're okay, I think. So we're just going to say what we're supposed to be doing. Mapping tree. Mapping tree. Oh. Dot. Use string. Let's see if this works. Well, yeah, we deleted it, so you know. Oh. Okay. What did it do? Well, it printed a tree. But there was nothing. The tree had no children. So that's good. But we printed a tree, so you know. Woohoo! Okay, let's make it do something more useful. Now, okay, there's a bit of an issue here. I've got a random when there. There's sort of like a bit of an issue here because what we're saying. No, I suppose no. This is okay. No, it's okay. I was thinking of something else. Right. So okay. Build resolution tree. Well, here I've got resolution tree, but it's sort of like I'm just going to say mapping tree right now. It doesn't. We've not resolved much yet. I mean, we have, but so now we've got to iterate over the match mappings somehow, and then add them to the tree. Yeah, I suppose so. Just Love Rust. Love Rust. Just thank you. This is great. God, if you were doing that in C. Oh, what? Right. So we've got a key and a value. And the key is the EDA placement. So we're going to rename that to EDA placement. And the value is the part mapping. So the idea was that we're supposed to create a tree node with details of the EDA placement. Let's say placement label, and you just go format, and we're going to say EDA placement dot refdes, and then it's going to get more complicated after this, because in our test we said we've got these brackets and then we've got some stuff. Let's do this for now. Tell you what, let's just do this. Because you can implement display for it, and then you can do something else for it. Details. So I want to pass something in and get some formatted thing out. Formatted whatever, and that then needs to go into something and whatever. Yeah. Okay. So it's like something like that. Yeah, I think that's what we want to do. Because there's different implementations for each of the different placement details, right? Okay. Well, think about it. Okay, so let me say tree. And then we're supposed to be doing something. Leaves. Push, probably. And then what do you put on? What do you put on here? And you just create a new tree. Okay. Let's put on placement node. Right. Tree is going to need to be muttable. You could probably do it in a pure function, but you know, I don't really care too much about that. Oh, I'm mixing my cases, aren't I? Look. Oh, no one told me. No one told me. Oh, what happened there? There we go. So we got details. If it's a dip trace one, we want to return dip trace placement details. Tree formatter. Maybe, and then implement this, and then implement format for it. Maybe. Not sure. Because here we're saying format, and when you return something from this, it needs to implement display. I think. Implement display for this. I think. Yeah. And then you get the formatter. And then you write a string to it. Then you say a bracket and a bracket. But can you not go format as well? Yes, you can. We're going to say bracket, bracket, and then name, and then single quotes, and then a thing, and then a comma, and then a value. Oh, no. A value, and then single quotes, and then things. And then it's going to be something like self dot zero dot name and self dot zero dot value, like this. And the zero thing here, this is a bit weird because it's like a tuple struct. And then we're supposed to be supposed to return. What are we supposed to return here? We're supposed to return a formatting result. Oh, you go. Okay. You can use the API to do it, but you don't. And you write with a formatter the thing. That's it. That's what you're supposed to do, I think. And then this needs to be something that implements display. Is this how you do it? Maybe. I'm not sure. Oh, well, I guess we. It's not really a tree. It's more of like a label. Dependency placement details. Label. Okay. I'm not sure whether the brackets should be inside this. I'm going to take them out. I mean, I'm going to put these here because all the labels are going to have the same ones. The KiCad one's going to have the same thing and whatever. And I'm specifically not using the display of the details thing for this because we want to format them in a way that we want for the label. Let's see. Hidden type for whatever. Impl display plus. Yeah. Because this has got a lifetime. That might work. There we go. Let's see what happens. Okay. Oh, look. Oh, that was pretty good. That was a pretty good bit of rusting. All right, cool. You know, we've got R1 and it's one of these and J1 one of these. And the point is that when I start formatting the tree, you know, if we're using KiCad or whatever like this, then the details of how we print out the KiCad ones can get contained in a specific label formatter, and then you do it like that. Yeah, nice. But this thing doesn't care about how this tree formatter thing works. It just does what it does, and away you go. Yeah, nice. Nice. Happy days. Right. Probably could move some of this out of here, but it's all related to this variant builder thing for the moment. I need to know where you can put code inside a binary that's only for that specific binary, rather than just making this file massive without adding it to the main library. I'm not entirely sure whether that's exactly what I should be doing if I'm doing this, because it might be that I'm supposed to just have an application crate with, like, you know, a single binary and structure the project that way. I don't know. We can work some of this out later. All right, so we've got that, but what we said we wanted was the manufacturer and the manufacturer part number underneath this. So we're going to do that in the same manner, I think. So we've got this placement node. Now, if I put that on there, does that mean I can't modify this down here? It probably does. So let's go placement node dot leaves push. And then we're going to say, what is this going to be? This is going to be the part. Yeah. Part node. Then we're going to create a part node. Then we go let part label format. Parts, to be fair, are, there's nothing special about parts. I can't remember what we said we wanted. We want to manufacture. That was it. And an MPN. Oop. Part mapping dot part dot the comma part mapping dot part dot movement. That. There we go. Okay, fine. Let part node. Yes, I know I could do all this on one line, but no. No. Adding locally named variable, whatever you want to call them, adds value because it describes the intention of what you're trying to create. Is tree node new? What am I doing? New. Then we go part label. Okay. But this needs to be muttable. Okay, fine. I spelled this wrong, haven't I? Look. Thank you. Pass or fail. I'm going to go fail because there's going to be some minor formatting error, but it might pass. Fail. Well, at least I guess right. I mean, yeah, look at this. Look at that. Yeah. That's sort of what you want. Mapping tree. Who can see what the problem is? Who can see what the problem is? Let's go. Let's look at it. Here's the test. What? Why is J1 before R1? It's a little odd, don't you think? Because we process the list of parts like resistor first, connector second, but when this comes to do whatever it does, it's got them the other way around. Why would it be do? We're pushing. Right, so maybe we need to do append. No, it's not append. Because append adds another tree. Okay. Let's have a look at the example. Is it because we're getting the things out of the hash map in the wrong order, or because we're adding them to the tree in the wrong order? Hmm. 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 That's really nice. Just I do feel that using the emojis for this stuff is going to be pretty good. Um, just wondering how they can make tree and it just make node and then empty. Are we insert? What's empty? B tree map. Yeah, it's using push. Uh, hmm. What we're going to do is we're going to print out the placement. Now, I don't normally like doing println debugging and stuff like this. But I still have this problem with the binaries not doing it, and this code is living in the binary. So, it is what it is. EDA placement doesn't implement display here. It's because it doesn't have debug. Oh, yes. You got to do that. So this will tell us which order the iterator is going to is running in. Right. We got J1 first. Okay. I mean, that was useful. So we know that the order of the things in the hash map is not what we were expecting. So let's see how things are added to this hash map. It's because I've got insert here. Oh, it's not a sorted hash map, is it? It's just insert. Okay. The hash map doesn't care about like ordering or anything. Hmm. Maybe we shouldn't be using a hash map here. Maybe we should just have a tuple structure of stuff, or just a vector of result objects, which is probably actually more like what we want, because some of these result objects could be fails, for instance, in the case where it doesn't actually map something to it. So let's not use hash map. Let's not use hash map. No. We're going to say it's going to be a vector of processing result. Yeah. Why not? This processing result is going to obviously needs to be public. Right. And it's going to contain the things that were in the hash map, which is a reference to an EDA placement and a reference to a part mapping. Therefore, it's going to have some lifetimes, which is fine. And it just happens they're the same lifetimes as these ones. So that's nice. And we're going to have EDA placement. And part mapping. Seems reasonable. Okay. And then this vector is then going to retain the order. And it's all going to be fine. So the results is not going to be one of these. It's going to be an empty vec. Fine. And then we're going to insert a processing result of placement and part mapping, right? But I'm going to rename this and use the same thing so that we can use this structure thing. Why? Oh, you go push. Right. So we've got this now instead, which is fine. And I think I don't need it yet. Okay, what's going to happen at some point in the future, not right now, is that this is going to end up being a vector. Because it can potentially match more than one thing. But right now, we don't need it. So this process thing is called by this. And I changed this yesterday to be a hash map, and now it needs to be something else. It needs to be a vector of one of these things. No, not that. Not that. What? Wait. Yeah, see, what I'm trying to do is switch to the test using Control Tab on my keyboard, which is what you do when you're writing Java stuff. You have a test file, and then you have the implementation file. In Rust, this is one of the things I don't quite like. In Rust, you end up having to sort of scroll up and down the same file like loads to get between your tests and your production code. You could do a split window view, but it's not as practical. I think the IDE lets you create a new window, a new editor tab for the same file. Opening, no. Configure editor tabs, no. Split and move right. So you can do this, but then can you take this and put it back over here? No. You see? No. You see? Scrolling. 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 You have to do this all the time. So, no, not a new hash map. It's going to be a vec of some stuff. We're not going to do this. Oh, no. I suppose I can do this. We said we're going to processing result. EDA placement and part mapping. What? Oh. Why didn't you guys tell me? It's supposed to be a comma in it. Import. We're in the part mapper one, yeah. See, processing result, lots of processing results. It doesn't need to be mutable anymore. Okay, let's see if this works, because if this doesn't work, then there's no point trying the other stuff. The other stuff is going to need to compile. Processing result, yeah, and the lifetimes of these things are the same as these things, so that's handy. There we go. The block. Right, but it doesn't. This processing result doesn't implement the things, so we need to derive them. Partial EQ. But it only needs to be implemented for tests. Oh, there we go. My brain's getting a bit ahead of me there, and it also needs to implement debug. Oh, okay, I've lost it again. This processing result. And I think it only needs this for tests right now as well. And then we don't use the hash map anymore. Neither here nor here. Tampoco. Neither. In Espanol. Okay. All right, fine. So does it work? It does. Excellent. So now if we go back to this and run this, this will tell us where we are with this. So what we said was we've got a vector of these things, and then we've got match mappings. Cannot be formatted because it doesn't use this. Fine. So where we've got this processing result, this debug thing is, oh, no, this one. Needs to be moved out of there so that it's here. Take one of those. Right, okay, that should do it. Let me say go. And then this isn't expecting a hash map anymore. It needs to be the same type as whatever this is. Oh, I suppose I could change it. I could use the IDE. Why didn't I just use the IDE then? Why did I start copying things to the clipboard and everything? Why? Just have faith in your IDE. But now we can use the destructuring syntax of this, I believe, which might have been correct anyway. No. Another reason to love Rust. You didn't have to muck about. The destructuring syntax is brilliant. If anyone doesn't know Rust, by the way, and they were just wondering what the hell is going on here, this says I want to create a local variable called part mapping, which has the same name as the property from the processing result object, which is returned by this iterator. Brilliant. It just makes this stuff like so nice. And refactoring it, like you just saw then, from a hash map to a result object. It's just trivial. Trivial. Oh, we're having a good day today. I'm going to put a space there. Yeah, it's private. That's fine. We make it pub. No. Pub private things. It's a data object. It's fine. It's got no behavior. Leave me alone. Hash maps. No. Go on that. Winter. I don't know where that came from. EDA placement. What? Not that one. Run it again. See, quick tip of the day. If you've got warnings, start from the bottom one first, because then the line numbers don't change. And then when you click on the one above it, it still works. But if you start from the top and go down, the line numbers are wrong. And then when you click on these things, it takes you to the wrong line because it doesn't sync the line numbers with your edited changes. It'd be nice if it did, and technically it could, because it's got this 11 here. So you're like, why can't it update this? It knows until it's a line. Okay, cool. Maybe I'll add that as a feature request. It'd be nice. Oh my god, we printed a tree of stuff. Amazing. I think we've actually got a useful tool at this point. Except that, I mean, what you could make this tool do next is rewrite the placements file using manufacturer and part codes. And then you would have a useful tool. That's pretty cool. This is great progress. I feel like we need to do a commit right now. Yeah, this is awesome. This is great. I love it. All tests. Run all the tests. Off you go. Brilliant. All right. Everything passes. This is great. Fantastic. Fantastic. Ah, yes. Happy days. Happy days. Oh. Right, committing. That's what we're doing. Right, commit message time. Let's go. What do? We... And if you remember from yesterday, or maybe previously, you go, if you're doing pair programming and you're trying to work out what to type in your commit message, you go, we, and then you look for the thing that you did, and then you explain what you did, and then you type that into the commit box. We updated the variant builder. So that it prints out a mapping tree, right? And we fixed some indentation, which, you know, look, and it's done it again here. Like, I don't know why. Okay, look. Let's do these indentation things as a separate commit. Fix indentation. Editor mishap. I don't know why it did this, but we want these things and we want this. Okay, done. Right, off you go. Now we go back to the variant builder, and what we were saying was print part mapping tree. Capital P. So this is what we said. Okay, yeah, that's all related to that. So yes, we'll take that. And in order to do this, we added a dependency for term trees, but we didn't add the dependency. It was already a transitive dependency. Ha! Which is why the cargo lock file doesn't have anything else changed in it other than Termtree, because it'll probably be already down here somewhere. Cool. Right, and then we had to update the part mapper so that it returns a vector of processing results, so that the order of the things is kept, and also so that, you know, we can properly define our processing results, because we know that we're going to change it over time. And then we've got this variant building. We've got a bunch of changes there. Did I skip over that a bit too quickly? Yes, I did. And in order to do that, we had to define a processing result, and we updated the test to do it. And we did that. Yeah, fine. So then our variant builder now has a bunch of code to do with formatting tree labels for the various different types of things that you can print out. And there was this random when thing there, which I must have copied over from a test, I think, when I decided to work out how to call the processor thing. When I called this, you see, I copied it over from the test. That's where that came from. So we build a mapping tree and we print it. Okay, and we build a mapping tree. In order to build a mapping tree, we need some formatters and some labels, and away you go. Okay, cool. Done ski. Check for unversioned files. No, just the IDE stuff. Probably should add that to .gitignore at some point, but not in this commit. Oh, why didn't it do that? I didn't click it, did I? Well, at least we're not using Subversion. Who remembers those days? Who remembers using Subversion instead of Git? When I first had to start using Git, I was like, what the hell is this rubbish? Ah! I wouldn't go back to Subversion anymore. Ugh. Ugh. I mean, we should push this. We should push this. Git. Push. Part mapping tree. Fix indentation. And it lists these in reverse order, which is weird. Most recent at the top. Push. push. Now, for those that didn't see it the other day, what happens now is on the project. Here we go. We have a build job. So when you push to master, it does it. And also, if you're doing pull requests to the project as well, it'll run these tests. And these are defined in the GitHub workflow, which is called this currently. It's basically a copy of the example one, and the only thing that's added onto the end of it is run the CLI test, because you need to specify the features for the thing. So we have this extra bit. So let's see if it. Let's see. Happy passing green tick. Happy badge. Yay! Everything's good, right? And we can go and look at the commits. And we can see that, there's ticks every time it did a build, right? And I did some pull requests against it the other day to test all this stuff out. So yeah, you can create pull requests if you want to contribute. I can't merge anyone else's code right now, though, because I haven't decided on a license. So if you wanted to contribute to this, give us a shout in the Discord. Feel free to create pull requests, and then we can have a conversation about what license that the code needs to be under before the pull request can be merged. Right now, I need to be flexible with a license, because I haven't decided what it's going to be. Right, so what's next? I think this might be a good place to call time on today's stream, actually. This is it's a good place to leave it. And then I'll have a think about what we need to do next. And maybe have a little break and a cup of tea. Yeah. Okay, so just remember, folks, it's only software. How hard can it be? We'll find out on the next one. See you later.